bases do with each other? Neutralize each other. They make neutral water. And why do they make neutral water? Can you tell me why they neutralize each other? Yeah, we know that they neutralize, but why would they neutralize? Equal charge. But any other reason? Why do they make water? Yes, that's true. They make salt and water. But my question is why now what we have seen earlier, why do you think they'll make water necessarily? Yes, because as Pema has said, OH and H will combine. So one is bringing H plus ions, extra H plus ions, one is bringing extra OH plus ions. And since these two combine to make water, so water will be a necessary product. So they neutralize each other to make neutral things, which means which are neither acid nor basic. They in a way cancel each other's effect. I mean, yeah, as Dicky has said, they cancel each other's effect, they neutralize each other, and they or you can say balance each other, whatever. They uh, H plus and OH ions combine to make water. So therefore, salt and water are the two products. So for example, here we are showing that NaOH and HCl. So the negative ion of this one, OH, and the positive ion of this one will make your water. And the other two remaining ions, the positive one here and the negative one here, will join together to make another neutral product. See, this is a neutral or ionic compound, NaCl, which we call as salts. So salts, so one part of the salt, if you look at NaCl, our ordinary common salt, one part of this, the positive part has come from a base, and the negative part has come from an acid. So a salt has contributions, equal contribution from one acid and one base, right? And depending on which one is strong, if you make a salt out of one very strong acid, this portion of the salt will become strong and dominate. If you make a salt out of a very strong base, then this portion of the salt will be strong. So salts also are weak and strong depending on what acids and bases have combined. Here, NaCl is a very, very strong means stable, a very stable salt. I mean, it's not easy to break up NaCl. Even if we heat water a lot, I mean, you take water, you put NaCl, it will not change into anything. It will remain NaCl because both of these are pretty strong. So even if you melt it can melt at very high temperature, but does not break easily. It only breaks with electricity. I mean, it's possible to do electrolysis, passing electricity through either very concentrated solution or molten salt. Then you can break it up into sodium and chlorine. Otherwise, they'll not break up. This is a salt which doesn't break up easily. So as I said, comes from base, comes from acid. And here we have talked about universal indicator. I mean, in this series, which this is again a series we made, but you can see the variation in color is very smooth and very beautiful. Like all the 7 colors have come so nicely. So now come to their reactions. So what will happen? What do you expect will happen if you put a metal in an acid? What do you think should happen? So somebody has said hydrogen gas is released, but why? Why do you think hydrogen gas is released? Because metal will displace hydrogen. Excellent. So as Pema has said, do you see that here is acid has this positive ion, and now comes some metal, and this metal has to have stronger affinity. We know metals themselves make positive ions because they are ready to give out their outer electrons. So zinc is desperate to give out its outer electron. So what it will do is replace hydrogen from here. It must have stronger affinity for chlorine. So if it has stronger affinity, it will kick out hydrogen. and join with Cl. This will make the positive ion. Cl is already the negative ion. So the hydrogen H plus is displaced. H plus is given its electron. You go away, you take your electron and go out. So hydrogen goes out and two hydrogens combine to make H2 gas. So we are going to show this reaction. We have a video also, but if Manisha can show, Manisha, will you show? Let's try. Sometimes, you know, I mean, the reaction doesn't happen very well. So we'll try showing it. And a good idea is to put a balloon on your test tube, because will you show through the tab? So I will spotlight tab. So we will collect the hydrogen in a balloon, and it's great fun to actually burst that hydrogen. We know hydrogen is inflammable and burns with an explosion. So in a balloon, it's done easily and without danger. So I mean, reasonably safe. Because otherwise, if you collect, yeah, it makes not only a soft pop, it makes pop, pop like that. I mean, it's an explosion. If you have greater amount of hydrogen, it'll explode. So that explosion in a balloon is great. So right now Manisha is putting dilute acid. I mean, dilute is safer, but if it's not good enough, we will make it a little more concentrated. So she's put now dilute acid, HCl, and now she will put some metal into it. So either you can put zinc. Are you putting zinc? Okay. So she's putting some zinc metal, or you can even do aluminum. I mean, like aluminum foil. So that also works. So see, zinc comes in big chunks. So yeah. So effervescence is observed. We'll try. AC band karna. So you can immediately see that there are bubbles in the solution. The reaction is started, and we will immediately put a balloon over it. So and actually a thin balloon, that holy balloon, works better. If you put a thick balloon, it creates problems. It doesn't burst easily. These thin holy balloons burst easily. They will collect some gas. Is the balloon secured on the mouth? And we will burst it with the help of an agarbatti, so that you don't bring your hand close to it, because that may be a little risky. So with a burning agarbatti or any stick at the end of which you can light up with a flame. So with that, we will burst it when some of it gathers. This fast reaction going on here. I mean, if acid is too dilute, then this will be slower, but this is reasonably fast, I think. We will let it collect for a while. Acha, Manisha has already prepared a larger balloon. This one is pretty large, so just be careful. She will burst this one so that we have a nice explosion. But please be careful. I mean, just like keep your hand. So she will burst it with the help of a agarbatti. See, that one started blowing, the pink one started blowing up from the bottom. So we'll burst both. No, quick, do. Agarbatti is burst. नहीं, agarbatti तो जलनी चाहिए ना. Yeah, Priscilla is saying when they were doing it, and it was so vigorous that it burst, and all in the lab nearly passed out. Yeah, it's kind of dangerous. So that's why balloon is a better. It won't burst like this. we'll get another agarbatti because it must have a flame. She's suggesting that we should keep away other test tubes. And if you're scared, then burst the smaller one. No, it's not the bursting of the balloon. Somebody saying balloon doubles the sound. The hydrogen cell makes it quickly, it'll go off. Did you hear? Usko करोगे आप? This was like a pataka bursting in our office. Do you want to burst the other one? The other one will be small, less loud, but still I think you should burst it. Good, great. So let's clap for these girls. Earlier we had men in our office. They were less scared, but now our girls are also getting brave. Yeah, so earlier, that big a balloon would burst with a real loud sound. It's not only because of the balloon, it's because hydrogen is very explosive. It's very explosive. So yeah, good demonstration. Okay, friends. Yeah, bringing a burning candle will also work, but you can't keep your hand very much away. No, at least agarbatti gives you a stick, which gives some distance to your hand. So I prefer an agarbatti for safety's sake. So, okay, friends, it's good to do, but I think you should burst when the balloon is small. Like our pink balloon was smaller. At that stage, there'll be an explosion, but not a very loud explosion. They're showing me the balloon. The balloon has a big hole now. Acha, Manisha wants to show that, look at this balloon. This balloon itself did not burn. Like it just, there was a hole created from which hydrogen burst out. Balloon itself did not catch fire, which happens with thin balloons, I mean, those holy balloons. If you have a thick balloon, the balloon rubber itself catches fire. So that's not so good. Okay, so I'm moving ahead because we don't have very much time. We want to show you other experiments also. So let's see. I hope we are able to show. So this was a reaction of acid with metal, and zinc chloride will be created and hydrogen gas, because Zn makes the positive ion and chlorine the negative ion. So this is the usual thing. Acid plus metal will give you salt and hydrogen. Universally, this is what happens. Now, what should happen when base is reacted with metals? What do you think? For example, here's a base and here's a metal. And please notice the base already has a metal ion. Na is already there. So what can happen? Metal oxide. But friends, that doesn't sound logical. I mean, after all, there is already a metal and metal hydroxide is there. So why will you get aluminum oxide? I mean, see, aluminum anyway cannot replace sodium. So base plus metal actually shouldn't happen. They don't neutralize each other. Salt and water is not created in the normal sense of the word. See, this reaction should not happen because there is a positive ion here, which is itself a metal, and there's a negative ion, OH. So aluminum cannot replace sodium unless, see, if it was aluminum hydroxide, because sodium is a stronger metal, it could have replaced aluminum. But in this case, it can't be simple replacement. Like somebody says, a reactive metal will displace a less reactive metal, but here aluminum is not more reactive than sodium. So this reaction should not happen, something else happens. Yes, as Na is more reactive, this should not happen. But this reaction happens to do something else. Something strange is done, and also hydrogen is released. So we want to show this reaction. Now, we will take NaOH, a strong base, and we will put aluminum in it, and we will do it in a conical flask. So if conical flask is not ready, so I'll first, she's just going to get a conical flask. So I'll explain what happens. I mean, we have it in a video also. What happens is, this is something special happens here. See, actually, aluminum cannot replace sodium because sodium is much stronger, much more reactive. Instead, aluminum makes another negative ions. See, normally aluminum should make Al 3 minus, I mean, like aluminum ion, but it doesn't make aluminum ion. It makes aluminate ion. This is a complex ion, AlO2. So aluminate ion. So there are these. Yes, as somebody has also said, Roji has said, sodium aluminate, sodium zincate. So there is aluminate, silicate, zincate. There are these another series of ions, which are these ions have the negative ion. Notice the negative ion has some metal, but metal has already combined with oxygen, and is because of the oxygen, it's making overall a complex negative ion, which is called aluminate or zincate or silicate. So either there's a metal or a metalloid. So that's why, because aluminum is able to make this, therefore you have sodium aluminate made and hydrogen released. It's a very interesting reaction because you can do it in a ready. So ये टैब से दिखा रहा होगा. So I'm spotlighting tab. So here we have a conical flask, and in which Manisha is pouring sodium hydroxide, which is our strong base, and this reaction is very beautiful to see, and it's less dangerous than the earlier one because the hydrogen actually doesn't escape out. You can burn it while it's inside the conical flask. So you are waiting for matchbox. And Manisha will be putting some pieces of aluminum inside. So some pieces of aluminum have been put inside sodium hydroxide. And very soon we will see a very vigorous reaction happening inside. I think that would suffice. Do you have a matchbox? So to not allow the hydrogen to escape, she has covered it with aluminum foil itself. So that the hydrogen generated is collected inside the flask. Let's see, when this happens nicely, it's a very beautiful reaction. I have a feeling the liquid is less, or it's okay. Is the reaction happening well? I can see very little liquid. Like aluminum is barely covered. Yeah, it's not possible with all the metals. With aluminum, of course, it happens because aluminate is formed. Zinc happens because zincate is formed, but won't happen with all metals. You are right. Has the reaction started? Can we see? And she's now covering with aluminum foil to allow the hydrogen to collect. Though at one point it becomes so vigorous that even if you are not covering it, the hydrogen released is enough to burn. So I think there's very vigorous reaction. Can you bring the camera close and show? Lift it a little higher. Lift a little higher. Yes. We can see that there's you can see a lot of vigorous gas is coming out. The solution looks white because of so many bubbles. So a strong reaction is happening. We will allow it to happen for a little more time so that you can see it clearly burning. I think now we should be able to do it. So what we'll do is remove the foil and put a burning matchstick inside. I mean, we have to not allow the hydrogen to escape. Put it inside. Oh, the match is a little wet. No, hydrogen had escaped, or maybe enough wasn't generated. So meanwhile, we will let it collect a bit more, or maybe you can put stronger NaOH. See, if the NaOH is too dilute, it will not happen. So meanwhile, maybe I will show you the video we already have. We already generated. So I will show you. And if so this we have put on our YouTube also. The same reaction. अब थोड़ा सा पानी, ये बहुत तेज रिएक्शन है लेकिन स्टार्ट होने में जरा सा वक्त। No sound is coming. Is there no sound? No sound. I think I have made my sound. Just a sec. I don't think sound is coming. रिएक्शन स्टार्ट हो चुका है। ये देखिए, इसके अंदर जो हाइड्रोजन बन रही है वो जलती जा रही है लगातार और रिएक्शन तेजी से बढ़ता जा रहा है। अब रिएक्शन खत्म हो गया। रिएक्शन क्या हो रहा है ये आप ऊपर देख सकते हैं। एल्यूमिनियम और सोडियम हाइड्रोक्साइड थोड़े पानी के साथ मिलके सोडियम एल्यूमिनेट बनाते हैं और हाइड्रोजन निकलती है। ये this you saw, I mean, in our recorded video, and maybe Manisha is also ready. This time there was a loud explosion because there was too much hydrogen. लगी तो नहीं? Dicky saying it's dangerous to do with sodium. You mean sodium hydroxide? No, there is no danger really. Sodium metal, of course, we should not use. I mean, aluminum is quite fine. Yeah, Na metal, of course, you shouldn't. So anyway, now we'll move ahead. Like I said, sodium aluminate and hydrogen is. Now let's come to carbonates. See, carbonates are simple. We have H.N. Pradhan is saying that it is effective for higher classes teaching faculties only. H.N. Pradhan, this is for 9th and 10th, this is perfectly fine. But when acids base come earlier, for them you can show them indicators, tastes, and minimally I think we should tell them why. Manisha ma'am ke liye claps aa rahi hain. So yeah, for earlier classes, it's good to tell children why acids and bases are important categories. I mean, often teachers leave it with taste. Then a child might think, why are we not talking about sweet taste and salty taste? Why we talk about sour taste and bitter taste only? See, it's not because of taste that acids and bases are important. They are important because of a completely different reason. And at least minimally, we should tell children why they are so important. Now we are coming to, so for 9th and 10th, we are coming to another category of reactions, which is reactions with carbonates. So actually carbonates, these are themselves salts. Carbonates, sodium carbonate or sodium hydrogen carbonate or bicarbonate. We call this bicarbonate also sodium carbonate or sodium hydrogen carbonate. Right. So what happens with these is if suppose sodium carbonate is combined with an acid, what happens is carbonate ion is a very weak ion, very weak negative ion. So chloride is very easily able to replace it. So what you get is this intermediate reaction where the acid generated is carbonic acid. You remember I mentioned carbonic acid is an acid you get in soda water. So carbonic acid is generated and sodium chloride is made because chloride ion is much stronger than carbonate ion. Here the reason is being of the ions having being stronger or lesser. Carbonate ion is a very weak ion, so chloride simply replaces it here. So this acid is so weak, H2CO3 or carbonic acid is so weak, it breaks up into CO2 and H2O. So for any reactions with carbonate ions, carbonates and acid or hydrogen carbonate and acid, you will get CO2 and H2O. You will get one salt, which is NaCl, and the carbonic acid will break up into CO2 and H2O. So do you think we are in a position to show? I'm showing both these results. Metal carbonate plus acid will give you salt plus carbon dioxide plus water. Metal hydrogen carbonates plus acid will also give you the same thing. Manisha will be showing. So Manisha is showing quickly. Yeah, so salt, water, and CO2 will show you. So meanwhile, while she's making the arrangement, I will go ahead because our time is nearly over. So friends, those of you who need to go at 1:30, you can go. But if you have little time, we will finish. There are a few reactions remaining. We'll do those. So what do you say about metal oxides and acid? What will happen? Suppose we react magnesium oxide with HCl. Any guess? What will happen? So I have one answer. Yes, magnesium chloride will be formed, correct. And water. Why water? Because you can see the Mg part will combine with Cl part, and then you are left with H and O, which will give you water. So salt and water is the, so it's almost the same way as magnesium will combine with HCl. Similarly, here um, MgO will also combine with HCl. But of course, hydrogen will not be given out in this case. In this case, we'll be having a salt and water. So here's the reaction shown, uh, salt and water. So let me see what all we are able to show you. I mean, our reactions are nearly over. What is Manisha showing? I'm stopping share. So Manisha is ready with sodium carbonate, which is our washing soda, and sodium hydrogen carbonate, which is our baking soda. Sodium bicarbonate, baking soda, sodium carbonate is washing soda. So both kind of sodas which are generally used in households. So here she's taken sodium carbonate, washing soda, and she is putting sodium bicarbonate, which is like your baking soda, in one test tube. So soda in both test tubes, both kinds of sodas, and she is putting some acid. So HCl is being put in both, and there's immediate production of this strong effervescence, immediate production of carbon dioxide, and you can check carbon dioxide by bringing a burning splinter or a burning incense stick, अगरबत्ती. So please light an अगरबत्ती and show. वो डालने से पहले अगरबत्ती जलाते ना. Yeah, there's lime water test also, which takes a little more time and some preparation. We can do that. Lime water test is beautiful, but I mean, takes some amount of preparation. And again, chuna that you can get from a pan shop. So in both these test tubes, we have carbon dioxide being generated, which we can, so we will put the this into the test tube. You can see that it immediately gets extinguished because of carbon dioxide generation. The effervescence has nearly stopped. So I think before the effervescence starts, we should, but anyway, like we were able to see the splinter getting stopped. Are you going to show magnesium also? But magnesium oxide with, we won't be able to show that. Doesn't matter. We'll now, anyway, the time is over. So I will quickly get to why are acids and bases such important category of chemicals? What do you think, friends? Why are they important? Because we give them a separate chapter and all that. Yes, they are not only used in our daily life, but they form a number of very important compounds. They make salt, they neutralize each other. So often they are in so many applications, they are needed to neutralize each other, and in so many other applications, they are used to make salts. And so that's why they are important. And I just want to say one or two sentences about strong versus weak and dilute versus concentrated. Uh, so Roji is saying they are also present in nature. Yeah, in lot many forms we can have acidic soils and basic soils, and in fact some crops grow very well in acidic soils. Some crops grow well in basic soils, but too much acidity is harmful for crops. Too much basicity is harmful, and for correcting the soil also the other thing has to be added. And we have heard about acid rain. So whenever there is too much pollution in air because of gases, sulfur dioxide, nitrogen dioxide. So then when rain happens, all those things come down as acid and make our water bodies acidic. So acid bases have very, very important applications. Um, just talking about strong versus weak. See, strongness and weakness depends on what uh, uh, what metal ion or what non-metal ion have made the acid or the base. See, for example, NaOH would be very strong base because the sodium itself is a very reactive ion. So, in contrast, magnesium hydroxide would be less reactive as compared to or less strong than sodium hydroxide, because if its components are very strong, very reactive ions, then it will be a strong base. Same with acid. So HCl is a strong acid because chloride is a very strong ion. As compared to that, I just told you carbonic acid, HCO, H2CO3 is a very weak acid because of its the carbonic ion is a very weak ion, hardly has much reactivity. So this strongness and weakness depends on what ions are present inside, whereas dilute and concentrated. So you know what happens. Wait, strong acids typically break up more in a solution to yield much more H plus ions. So if there are strong acids, HCl if you put, it will much more of HCl will break up into H plus and Cl minus, and therefore your indicators will show the presence of a very strong acid. But a weak acid will not show as much presence. It will not break up completely and will not show as much presence of H plus ions. Same happens with concentrated with dilute. I mean, we dilute often with water. So a concentrated solution will show greater presence of H plus ions. A dilute solution will show less presence of H plus ions. And I mean, this is what we are showing, that the number of H plus ions in your solution keeps decreasing as you dilute. Yes, as Priscilla says, yeah, Anju Bhatia has said something very important. A whole lot of our body reactions, body system reactions depend on acidity and basicity. As you will remember that in our digestive system, the first part is acidic, till the stomach it is acidic, and then it changes the medium, it becomes alkaline. So the stomach enzymes can work only in acidic medium, the intestinal enzymes will work only in basic medium. So some people who have a problem with their liver or their bile juice and the medium cannot be changed, cannot digest. So digestion gets badly affected because our enzymes require a specific medium, specific pH to function. So that's why in our body also acid and bases play a very important role. And as Priscilla says, understanding properties help children visualize more clearly and help them understand higher concepts. So friends, with that, we are actually ending with our session. So we showed most things other than acid oxides, metal oxides. Metal oxides actually work like bases. When they are dissolved in water, they become metal hydroxides, which are bases. So MgO, if we burn magnesium to give magnesium oxide and we dissolve it in water, it becomes MgOH, which is a base. So metal oxides in solution become bases, and they show all basic properties, alkaline properties. Yeah, so we do that showing indicator. So if we have time, we show it, otherwise. But we have shown you most of the things, and the major discussions that we wanted to do, we have done for today. So we will end here unless you have a question or comment. And